Welcome everyone. Welcome everybody. Good morning, good afternoon, depending on from where you're listening. Very happy to have you on board for our webinar today. Together with Gerard from Arista, we will talk about a technology briefing, giving you some insights what we are going to talk about IBC. Gerard, welcome.
Hi,
How are you
Thomas.
doing?
Yeah, I'm good. Thank you. Thank you for the opportunity. It's always good to. I'm very excited about IBC. There's lots of new stuff coming up, and it's great to be working with you guys.
Thank you. And for those who have not met myself, my name is Thomas Gunkel, Market Director Broadcast at Skyline Communications, based in Germany. Skyline is based in Belgium. This is where our headquarters is. Where are you based, Gerard?
I'm based in the UK. I've been with Arista for about 8 years now. I've got a focus on media and entertainment. Obviously, a heritage with used to work for Snell & Wilcox for 22 years. So I'm a broadcast guy, but I can speak IP. And the 2110 revolution, I think, continues. And I think there's often a lot of topics that we talk about a lot of stuff generally. One of the things I think we miss out a lot on is monitoring. So I'm very pleased to be talking about monitoring today.
That's also what we are going to look into today. Probably very unlikely that people don't know Arista, but for those who don't know, maybe you want to give a quick intro.
Yeah, sure. We've been around for a long old time now. We've been public for over 10 years. A large number of customers. We sell data center switching. That data center switching has evolved into campus switching, enterprise switching, WAN, internet scale routing, and more recently security. But also we've been in the media and entertainment segment for probably 10 years. Our heritage was multicast, high frequency trading, which of course required the multicast at scale and required PTP. And so those two attributes, along with quality, which is kind of our primary cultural value, makes us really suited for these kind of really important 24/7 live production media environments. And we've had a real good focus on that for a long time now. And you can see that coming through in the sorts of customers, global events that are all running through Arista-based switching and routing.
Yeah, thank you. And for those who don't know Skyline or not too much about it, Skyline is the company name. We are also out there since many, many years, headquartered in Belgium, a couple of hundred people across more than 25 countries in the meanwhile. And the one and only product or solution, we call it now digital transformation platform, is DataMiner, a solution to plan events, work orders, productions, monitoring. That's the main topic of today, but also to control, to automate, and to orchestrate and manage your resources. We are active in the broadcast market. That's the topic also for today, because IBC is upcoming, but also we are covering the satellite market, service providers, and rather new energy utility and smart ecosystems out there. Customers also on a global base, just a couple of those customers, our key customers we are working with. And most of them, and that's the interesting part, Gerard, those are also Arista customers. Because when we look into it, and that's a bit the agenda for today, our collaboration has started many, many years back, I guess, more than 10 years back. 2014 specifically, where we started the first integration, which was a connector still SNMP based. And then things have evolved. You came up with new APIs, new technologies, and we have adapted our way to integrate, right?
Yeah, and Arista has always been based on open standards and based on providing rich access to the state of the switches and the network, and making that available through many APIs. So it's what I find is our best partnerships are with organizations that use that data or manipulate that data through our APIs in order to give the end customer a result that is, more than 1 + 1 doesn't equal 2, it equals 3 or 4, simply by leveraging that rich data set and the ability to have these open APIs that they're also stable. We tend to not build when we make changes and additions, we tend to make it so it's backwards compatible. So partners like yourselves don't need to rewrite your end every time we make a change.
And when you look into how things have evolved, going from SNMP or starting with SNMP, then we did integrations via your eAPI. And today what we want to talk about is mostly about streaming telemetry. But before we look into that, maybe just a brief look into your tech stack. What is
sure.
about?
So I guess in a couple of words, it's quality, which is foremost, something that's going to work as you expect it to all the time, but also it's simplicity, and that simplicity, because we are a relatively young organization, what we have is the ability to start from, well, we started from scratch and we built our operating system from scratch. We built the entire monitoring stack, observability stack from scratch. And what that meant is we got a single operating system across every product with a single set of source code. And the outcome of that is real operational simplicity. It means it doesn't matter what switch you deploy, you can run the same operating system on it. It doesn't matter what switch you deploy, the CLI is the same. It doesn't matter what switch you deploy, the API is the same. And that means that from a monitoring point of view, telemetry point of view, configuration point of view, almost any point of view you can consider, it simplifies the end user's view of the network, but it also enables partners like you guys to be able to build it once and deploy it with any customer who's got an Arista infrastructure.
Yeah, and that brings me also a bit to a mini DataMiner introduction. What you just said, that's important for us, that we can interface with a single consolidated API to all your infrastructure. We don't have to build 20, 30 different integrations. We have one single, what we call connector. This is where we see the infrastructure down there. And by the way, very important, if you have any question, feel free to type them into the chat window. There's a possibility in LinkedIn, and we will answer those as soon as possible or after every of those sections during our conversation here. So with this API, going back to that, what we have in DataMiner, we have a data collection and control plane, and that allows us to read and set each and every parameter, different vendors, because we not only integrate with Arista, obviously, through those APIs and have full control over your infrastructure. What we call a digital twin. A digital twin is also more about nowadays getting administrative data. Here we talk about scheduling data, integration, maybe also with ticketing, plant maintenance systems, to really cover the complete ecosystem, not only the monitoring part, because things go together more and more. And then we have a set of what we call stack functions, an automation engine, to give an example, and resource planning management functionalities, a scheduler which is built in to build your own targeted solution. And how do you consume data? Either things happen through machine-to-machine interfaces, then there is an API, or we have user interfaces. There we have dashboards, low-code applications. We have an expert client called Cube. So many different ways for different teams, for different roles to consume the right data. And when we look into how does this look like for an Arista integration, we have all the Arista switches. We have two different Arista connectors as of today. There is one we have started many years back, going in via eAPI, and the more recent one, and that's the next topic, we have created a connector which is based on streaming telemetry, GNMI. And also, by the way, something we will cover later, we have integrations with Arista MCS. This allows us to have full control over the Arista switches, and then we also provide applications and user interfaces out of the box, or you can create your own ones to get the right data for the right people. And very briefly, before we look into streaming telemetry, if you're interested to try things out, that's rather easy. You can go to dataminer.services, try out a DataMiner system. That's for free for a while, even running in our cloud, or you can deploy it on-prem. You can download one of those Arista connectors and start with I call it a templated solution. We also provide user interfaces that you can download to have an operational user interface available, or you can build your own user interface as well, and over time adapt and evolve. Now, streaming telemetry, Gerard, you are the expert. Compared to traditional polling, what is this about?
Yes, good question. Tell you what, I'm going to jump back very slightly, and I'm going to say that in the same way that you can try out the DataMiner products, obviously you can try out Arista products if that's what you'd like to try and do. We've got a virtual EOS, which is a software version of our switching platform, which you can go and generate yourself a login at arista.com, and you can, as a guest, you can essentially download a virtual EOS lab image, which you can run on EVE-NG or Container Lab or VMware or whatever you like, and you can build your own network, and you can try this telemetry out yourself if that's what you want to do. So let's jump back then. So why are we talking about streaming telemetry? What's wrong with that stuff? What's wrong with SNMP? It's a great question. I mean, SNMP's been with us for a long time. It's done a great job. You've got the ability to poll stuff. You've got the ability to generate traps. But fundamentally, if you're polling stuff, you run into some scaling problems. And most of this is about scaling problems. So if you're polling stuff from one switch, you can probably do that every 5 seconds or whatever. You know, you can have fairly up-to-date data. But if you're polling that from 200 switches or 800 switches, you're into a world where you're probably only polling once every 30 seconds or once every 2 minutes. And at that point, you start to miss stuff. You can see here a very simple example of interfaces being up and down. You're missing things, right? In the case where you're polling it and you're not polling it often enough, it might just look like the interface is up. You would say, what about traps? And for things like interfaces, power supply failures, traps is not a bad way of doing it because the system will tell you when there's a failure. But if we jump to the next slide, traps for kind of, you know, throughput is not terribly useful, because now you can see if we, you know, you can't, how would you build a trap for bandwidth usage? It doesn't make a lot of sense. But with if you move away from streaming data, polling data towards streaming data, you can start to monitor that more finely. You end up with a better view of the ongoing bandwidth usage over shorter periods of time. So what the benefits you get with moving away from polling is streaming telemetry is event-based. So we send events when they happen. We don't repeat that. We send you power supply failed, and we never tell you about that again until the power supply is better. If you connect after the power supply has failed, we'll tell you the power supply has failed. So what that means is we reduce the amount of data we need to send to you, but that data is more timely. So you'll end up with a better view of what's going on with less data and with less CPU usage at your end to have to duplicate everything that's happened. So fundamentally, it's a better way of going. Can we jump to the next slide? And sure. With Arista's EOS operating system that sits upon our switches, it's actually natively built in. So at the core of every switch, we've got a concept called NetDB. It's basically a publish and subscribe database. Around the outside of that conceptually sit all of the agents that run on the switch. So whether that's the MLAG agent, the VXLAN agent, BGP, spanning tree, they all sit around the outside of this NetDB database. They publish their data into the database and they subscribe to things they care about. They hold very, very little local state. The state is held in this central database. And what that means is it has a lot of really valuable benefits for the architecture of the switch, for resilience, in-service upgradability, extensibility. But from a monitoring point of view, what it means is you can build an agent like an open config agent or an eAPI agent or an SNMP agent. And those agents subscribe to what they care about in order to be able to send that telemetry. And so if you look at an open config agent, for example, it subscribes to pretty much everything and it gets notified when pretty much anything changes. And so it can now easily stream that data externally to the switch with low latency and without interfering with the ongoing processes of the switch. It simply says to the state database, please send me all this stuff, please. The database does that. It publishes it to the OpenConfig agent. The OpenConfig agent streams that on. So we're not building a streaming telemetry system off the top of a naturally polled OS. We're building a streaming telemetry system off the top of a naturally real-time events-based streamed OS. We've jumped to the next one. And I mentioned extensibility in the last one. I just want to briefly say that what I mean by that is that, for example, there's lots of different streaming agents you could be running. You could write your own streaming agent if you really wanted to, and you could use the EOS SDK probably to do that. There are also lots of ways of consuming that streaming telemetry. We'll talk about Cloud Vision in a minute. Thomas will talk about DataMiner in a minute. I'm just going to say that this stuff is available. One of the questions would be why would I buy Cloud Vision, or why would I buy DataMiner? One of the benefits of EOS is you could build this stuff yourself. You could use open source, easy to consume tool sets like Telegraph, Influx, Grafana. But what you're buying into at that point is having a bespoke, hand-built thing that your operations team can use, and they can have exactly what they want. But you've got an ongoing operational cost of building it, maintaining it, and delivering what you want. So in the great scheme of things, you can choose almost any option you like. For those customers who don't want to go through all that, have a DevOps team building all this stuff, then Cloud Vision and/or DataMiner are great options for something that's pre-built and delivers massive value. Back to you, I think, Thomas.
And that's what we have done with that latest connector. Based on that GNMI, we have built a streaming agent where we receive everything via streaming telemetry. What you see here, that's one of those sample or solutions, low-code applications you can download from our catalog. First of all, it would automatically detect the network topology via LLDP. And then we use streaming telemetry, as you see here, to show bitrate in real time, but also things like SFP data, your RX, TX power on your fibers, and all of that together. And this is all real-time data. When an interface goes down, the simple example, we would immediately know, and there's no risk that you miss the fact when you would do polling. When you want to try it out, and here you see the operational states of such list of each and every interface. Whenever something changes, we would be notified in real time, and we will show that information in real time. So that application, feel free to try it out, available on our catalog. You can download it, or you can build your own one. And here's another example where we have done an overlay for PTP monitoring. You see the links are color-coded, interfacing or showing the PTP state, if it's master, slave, or passive, and also showing some real-time KPIs and metrics. And in that case, for PTP, we track mean path delay, offset from master, and some other metrics out there. And once more, we do it via streaming telemetry in a secure way. And we see that a lot with customers, Gerard, and I guess that's important. We talk to the broadcast teams. They are happy about the fact that they get notified in real time, but moreover, it's also the IT teams, which are not telling us we are not allowed to poll anything, because I guess that's important, and you probably want to comment. It's a lot about security, and this is the more secure and better way when you talk to your SecOps teams, when you use streaming telemetry instead of polling switches, where there is always a risk that we could oversubscribe the CPU if we do too much polling.
Yeah, I mean, that's a very good point. I mean, SNMP is a pull or a push if it's a trap. But you're absolutely right. One of the great things about the streaming telemetry is the amount of CPU that's getting used by that streaming telemetry is controllable by the switch. So if the CPU is doing lots of other stuff and has to, I don't know, slow down but it's streaming a little bit because of the switch having to reconverge its routing or multicast routing tables, for example, then the switch can make that choice to prioritize that operational nature. And of course, from a security point of view, having the switch sending streaming data natively from the switch is arguably a much more secure way than having a third party pulling that data from the switch, giving the third party credentials to receive or to ask for that data. So yeah, we definitely see it as an easier security cell to have the switch pushing the data to a third party than have a third party asking for that data.
All right, thank you. Before we look into the next topic around what we call advanced monitoring, we have our colleague David in the background tracking the questions. David, are there any questions so far we could answer?
No specific questions yet. I think there was one question that came to mind was related to SNMP, that it offers traps, and was it different with the telemetry? But I guess you partly covered that already.
Yeah, I think it's worth saying again, though. I mean, SNMP. I mean, if the question is why streaming telemetry, not SNMP, I think the answer to that is subtle in some ways. You're relying on polling for almost all the data, and that ends up being not event driven. It ends up being driven by the timing of the polling device, which means that you might miss stuff. What about the traps? Well, the problem is that there tend not to be many traps built into SNMP, and you're also starting, ideally, to get the same performance as streaming telemetry, you build a trap for everything. So actually, you're turning the whole model is now asking SNMP to become a streaming-based technology, which it never was intended to be. So architecturally, that's never going to work.
All right, thank you. There's one other question we have here in the chat, which is, can you visualize PTP tree from active GM to leaf ports? Would be very handy for troubleshooting.
The answer is yes, in a sense. What you saw so far on that example was only showing Arista switches, no extra media devices like PTP grandmasters, but we can also loop in those and show them in a topology overview. So it's not limited to the switch fabric only. We can also add the end devices, the receivers or slaves or PTP followers, and the PTP grandmasters.
Yeah, and so you can do it. CloudVision can do it as well. There's a topology overlay, which I would accept is sometimes tricky to make it look tidy. But
yeah, and that probably brings us to the next topic already. Cloud vision or monitoring.
Yeah,
Gerard,
yeah, sure.
you.
Okay, yeah. So what are we going to do with the streaming telemetry? So Arista has got a single pane of glass tool called CloudVision. Its job is to do many things: provisioning, change management, integration of some third-party functionality. But one of the big things is to make use of the telemetry. You can think of CloudVision as it's a network-wide database. So like EOS has got a database at the core, CloudVision has got a database that aggregates all of that, or all of the data that it's receiving through streaming telemetry. It's a time-based or time series database. So we have about 3 months of stored data, and that's pretty cool. It allows us to go back in time and look at stuff. And I suppose the question would be, well, why am I talking about CloudVision when Thomas is going to talk about DataMiner? And I think this is a really good question. CloudVision is obviously a network monitoring management tool. Arista is a network organization, network switch routing based organization. CloudVision is intended to be a very specifically be a detailed network monitoring tool. As such, it provides really deep information, deep insights into the performance of your network, the state of your network, how healthy is your network. It does. We're branching into we cover some applications. I would say you could consider campus to be an application. We cover PTP sort of as an application, but CloudVision is not going to cover it's not going to cover very deep broadcast functionality as an application. If you come to IBC, we'll show you some MCS monitoring that's been built into CloudVision now. But that's fine because MCS is one of our products. But what we're not going to do is give you the same sort of application workflow visibility as bespoke broadcast tool sets will give you. So think of Cloud Vision as a network monitoring tool, which is which is the tool that your network team and the network side of your broadcast team should be using. We do have some media entertainment type functionality, but think of it as logging, events, alerting, compliance, dashboards that you can configure to see the network state. The time machine capability, the ability to go back up to 3 months is incredibly powerful. The ability to use that to compare the state of multiple switches, your network at the same point yesterday at 3 o'clock when there was a problem or when the Wi-Fi went down, is particularly powerful. The ability to do those comparisons, whether it's in the state or in the configuration, is amazingly powerful. It wouldn't be worth us talking about this stuff without throwing AI in there somewhere. Obviously, there's a bunch of machine learning and stuff that's starting to help us to deliver insights into the network, whether that's root cause analysis or predictions of the state of the network in the future, whether that's kind of how heavily we're using it or whether optics might be on the way out. So there's a bunch of that stuff in there. And then I say there's not a lot of M&E specific stuff. The majority of it is things like PTP metrics. We have some flow tracking coming from different sorts of telemetry, and we can kind of make stuff a little bit easier to understand and view by the use of reverse DNS lookups if you've got DNS servers delivering you friendly names for IP addresses. But so in general, it provides a more network-centric view of the world.
Yeah, and that's also what we see a lot with our customers, that they use both tools. They have Cloud Vision, as you said, often used by the IT teams, and then they have DataMiner used by many other different teams, and maybe also by the IT team in parallel. Just another comment what I've seen, and I guess you can confirm, Cloud Vision is also used a lot for network provisioning. You have those, I forgot the name, sorry, snippets or something like that. There's a different name.
So I mean, we're focusing on monitoring here, but you're absolutely right. Cloud Vision also gives you change management and provisioning tool sets. Whether that's in fact we can now automate provisioning of layer 2, layer 3, EVPN, VXLAN, M&E networks. You can kind of provide a very high level view of what you'd like, and a tool set called Studios will then take that away and take that, I'm not going to say intent, but take that definition of how you'd like us to deploy the template, and we can deploy that template.
Yeah. And as you said, and as you have seen already, what we do with DataMiner, then we interface with the switch infrastructure, but we also interface with like all the media infrastructure, the endpoints and grandmasters, as we just talked. And next couple of minutes, I want to go back a bit to monitoring again, because monitoring often was based on, let's say, traditional alarm threshold-based monitoring, which is not working perfectly anymore in a pretty dynamic environment. What we want to do, and I will show you around a bit what we do in switch fabrics, is to replace those static thresholds with more self-learning and machine learning-based algorithms. And just a few things here. Those can be things like forecasting alarms, pattern detection, relationship learning. And I will show you around a bit what this is. That can be from, you see a screenshot, that's CPU utilization from any kind of system. And the things in red, this is actually a forecast of the behavior as it likely is in the future. On the left-hand side, this is also what you see in a DataMiner system, what you have also available in Cloud Vision. This is data we store for a few days, for a few months or years, whatever you want, but we also predict data. What does this mean when we predict data? Here is another example. You see those trends going slightly up, going slightly down. You can make good decisions towards the future. And towards the future might be something like this. Here is a real-life example of an Rx power of an SFP we measure, which goes slightly down. And you see here, this is the time of today, that dotted line. And what DataMiner has done, it was throwing an alarm saying there is a predicted critical alarm, that little rectangle up there, towards the future. So it did not breach the threshold yet, the absolute minimum or maximum. But before things actually go wrong, we send an alarm to the operators saying, when this trend goes on like this, what you see here, some degradation of your network quality or SFP quality, you will run into problems. That gives you some time to fix it before it's becoming a real problem, actually. Other things we see, those are again examples from switch fabrics, is detecting anomalies. We store historical data, and then we try to identify anomalies. And here you see a level shift. A level shift means typically the current was pretty stable. All of a sudden, it goes up a little bit. And when we identify that, DataMiner can make an estimate how likely it is that this level shift or this trend change in this example is actually a problem. And here you see data which was super stable for a while, and then all of a sudden it goes dramatically up. There is a trend that goes up, but it didn't reach an absolute maximum yet. So not like a classic threshold, but still we would already throw an alarm and say, this anomaly we have identified is very likely an anomaly which is worth having a look. It might be a problem. This is a completely different approach when you think about it than using traditional thresholds in your network. And another example, I always like that one, is flatline detection. You have a lot of metrics, and network utilization is one of them, where you never have the same value and a stable value. CPU, networks, it's always slightly changing. And when there is a flat line, you could not detect that with any classic threshold. We can also identify those. Maybe there's something frozen, a frozen operating system, something broke, half a life. That can cause behaviors like that a system reports the same value forever. We can identify those. Again, worth having a look. Very likely something is not quite right anymore. And one more example here. Here you see a total processor load, and you see historically that was growing a bit, and you can identify that. We see that. We can come up with a trend change. You might get even a notification or alarm, but you wouldn't know what the root cause is. And with relationship learning, what you see up there, DataMiner gives you other metrics that also show a trend change at the very same time, or a change in behavior at the very same time. And here you see that CPU utilization overall goes up completely, but then we split it down into certain tasks in the task manager that very likely some of those services are the problem. And when I look into those, there is one, the yellow one, which also goes up, and that at the end causes and is the root cause of your actual CPU utilization going up. So that's helping you finding the root cause, not only seeing the problem, but also identifying the root cause of the problem. And more of those examples or machine learning algorithms we use to make monitoring better. And that's key. And that's also something we are working together with Arista to see what are good use cases, what happens out there in reality, because we need real data. We need data from customers to learn, because this is all self-learning on the systems. That's not something we pre-train in our own lab. This is all coming from real customer deployments. And again, before we go into the last part today, David, any questions?
Yes, maybe good to confirm. So why do I need cloud vision and DataMiners? Why do I need more than one monitoring solution?
Yeah, I can jump in on that one. So I think in general, they are tackling different problems, and they're being used by different parts of the broadcaster. So Cloud Vision is delivering very network-focused data, and it also provides the provisioning and the change management and all those other amazing things that it does. And so is often used by typically it's used by the network operations team, possibly in the NOC. And it's likely to be being used by the networky side of the broadcast team. But what it's not doing is it's not attempting to provide you with any application-specific information. It's attempting to tell you about the health of your network. So it's half of the story. It's like a yin-yang thing, right? Half the story is the network, but the other half of the story is your application-based data set.
Mm-hmm. Yeah, and as we said, we see many customers using both applications. If you're interested in more details, feel free to reach out afterwards, and we can also connect you with some of the customers using both and give you more details on those. And with that, I guess we can look into the last part of today, which is more on the orchestration part. Arista MCS Media Control Service.
Sure. So, so MCS. What is MCS? So MCS is Arista's multicast orchestration system. It's the thing that Arista. Others are available from third parties, but Arista has saw the need for a high performance bandwidth aware multicast orchestrator. So MCS is our offering there. It's a thin layer of very smart software that sits between your broadcast controller and your switches, and it fills in the gap between the need to deliver multicast in a bandwidth aware way and the standard protocols that are available to do that, like PIM and IGMP, which standards based, they are not capable of doing that. So we're big fans of standards, and so rather than make up some new stuff, we decided to take that orchestration function and remove it, take it outside of the switching infrastructure. It's a very SDN sort of software-defined networking sort of architecture. There are some external servers who understand from the switches, they understand what the topology of the network is, and they understand the bandwidths that are required, and they understand from the broadcast controller where all the senders are. Broadcast controllers tell us what to connect together. We do that very, very quickly. We do it with this bandwidth awareness, and we provide a very, very quick tally. So we can support normal 2022-7 type networks, whether that's red blue or a purple type network. We provide very fast tallies back to the broadcast controller, so everyone understands what's going on. We have got a bunch of other functions that are coming along. So as people start building bigger and bigger networks, like BGP drain down, we've built a maintenance mode that allows you to gracefully take a spine, for example, out of commission. What that means is we won't put new flows onto that, and you can ask us to, move those flows somewhere else, and we'll do that. So that allows you to kind of build a maintenance-based 2022-7 style maintenance window using MCS as the tool that drains those flows down. And then the last slide, I think, from me, Thomas. What's new? So one of the things that's new is we've just released our MCS lists functionality. This is a way of bundling interfaces that are external facing from an MCS zone, if you like. See here we show 3 zones, 3 leaf and spines. We're starting to see people slice up their networks into smaller physical domains for resilience, for the ability to maintain things, to not have all your eggs in one basket. And so the ability to run multiple MCS zones, but then have them load balance between them, is becoming quite critical to scale these systems further than they currently are. And the lists feature allows you to connect multiple MCS zones together, or MCS zones to IGMP and PIM zones, and still maintain that load balancing capability. So if there's anything in there that's of interest to anybody, please, come and see us at IBC, and we'll be very happy to chat about it. So tell us, Thomas, how do you guys integrate MCS?
Yeah, how does this go together? There's, again, an API available for MCS. We have a connector for it, and here's a single slide that shows a bit reality out there with broadcast customers. When you look into it, here's DataMiner on top, where with the functionalities. Specifically, let's say we are in an MCR, you schedule your work orders, we manage like the resources, we provide user interfaces for end-to-end connectivity. What I mean with that, often your source is something external. That might be an SRT stream, something 6C transport stream, a non-2110 stream. You want to route it from the venue into your MCR. There is a handover point, converted into 2110. Then you have your 2110 destinations, maybe you convert it again into something different. Within your facility, you usually run a broadcast controller for live operations that can also be used in the MCR. But if you have a broadcast controller, the broadcast controller, as you said already, Gerard, integrates probably with Arista MCS. And Arista MCS configures then the network and calculates and sets the multicast routes. So to make a connection, what we are doing, we look into the, let's say there is an SRT encoder. We interface with that one. We configure the encoder. We configure then the 2110 handoff point to receive the SRT stream. Then we also send cross-point commands to the northbound interface of the third-party broadcast controller. The broadcast controller, again, talks to MCS. MCS talks to Arista, and we make an end-to-end connection. But you also see all those blue lines here. We interface with the switch fabric, with each and every switch, as we have seen, to get streaming telemetry. We do the same for Arista MCS to also get information from MCS, what MCS reports back. And with that, we get a full picture of what is going on in the 2110 world and outside of the 2110 world. And one of the applications or requests we see a lot is about multicast monitoring. What should I do when a stream doesn't make it from a source to a destination? And here is one example. You can just enter a multicast address in one of our applications and visualize the path from a source to a destination. This is something you can easily do. How do we do that? We talk to each and every switch. We read out multicast flow tables. That's the way how we can visualize it. But as you can see already, that's a bit of an IT-based tool. Nobody wants to enter multicast addresses, and you don't have any context. You can show a multicast, but you wouldn't necessarily know if that's a multicast you expect, if that's a multicast which is a leftover or an orphan. All you have here is something proven that you see a multicast, but context is missing. When you look more into broadcast operations, and here's another screenshot and example from actually the Arista lab, you need more, you need context. And context is often labels from a broadcast controller, because the broadcast controller is not dealing with IP addresses for the operators, but with labels. And that camera might have an IP 2110 video, audio, data stream, goes all together. That's something we need to read out, because if people have some trouble with that camera one, they want to work with camera one, they don't want to enter multicast addresses. And what you see here, we are comparing two different states. We call it the as-engineered path. This is something that has been configured in the network by the broadcast controller via Arista MCS, from that camera to that monitor, super simple example, through Arista MCS. And then we compare this as engineered path. So this is the state we know as it should be versus reality in the as is path. And there we crawl again through the network, from the camera through the monitor, and we read out again directly from the switches the multicast flow tables. Then we can see that MCS has chosen leaf 1, Arista's bind, and the leaf 2. We can compare it also against the information we get back from Arista MCS and cross-check each and every information, starting from a broadcast controller through Arista MCS, through the actual switches, to make sure all those systems are in sync. And only with that you get like a full picture of what is going on with your multicast flows. And that's again just a simple example of how things can look like. But for you to remember, it's really about, when we talk about flow monitoring or flow tracking in broadcast operations, it's not only about showcasing a few multicasts or flow tables in the network. We need that context coming from the broadcast controller, but also think a little bit further context coming from a maybe scheduling system. Because when would you know that you expect a signal being up and running? Well, when the event is up and running, then you want to have it. When we have this information available that there is a soccer game tomorrow for 2 hours, then we can also adapt the monitoring, we can adapt the flow monitoring to it, and can give you the full picture. And I guess with that, and with IBC coming soon, we are almost at the end of our quick pre-IBC webinar. Gerard, or before we look into what's going on at IBC, David, any other questions so far?
One question still is, can I use MCS with other dynamic multicasts?
Yeah, that's a good question. Yeah. So MCS you can use MCS to manage you can use MCS in conjunction with IGMP and PIM if that's what you need to do. So you can have non-managed multicasts as well as MTS managed multicasts. And we do actually see that sometimes. There's often, I mean, there are some broadcast vendors that use multicast as their registration discovery protocols. There are other customers who are looking to, for example, simplify the way that they manage their multicast. Maybe the audio and the metadata from 2110 is not being MCS managed because they're very small flows. So yes, short answer, yes, you can absolutely do that. Come and see us at IBC and we can chat that through.
Good, thank you. So 1 more week to go, I guess. We will all be at IBC. As you see, we are in Hall 1. Arista is in Hall 10. Gerard, there's one event you want to mention that you have on Friday,
yeah, sure.
Right?
We have an advisory board event on the Friday evening. If you would like to come along to that, it's an opportunity for us we talk about our vision and what we're doing next. And we typically have, in fact, we're focusing on automation this year. So we've got a view of where our automation is going to, and we've got a customer automation story. You get an opportunity to meet other, system integrators and vendors and partners and other customers. So it's typically a good event. Give us a shout if you're interested. Thomas, I hear you've got some beer or something. Is that happening?
Yeah, true. As a German or Bavarian, we are pretty picky on beer. I have to say Belgian beer is good. And this year we offer beer at 5 o'clock every day from 5 to 6 at our booth. So before you run into the Arista event and join that one, feel free to have or pass by, have a beer with us, and we can discuss your needs and have a look at your workflows and everything you do together with Arista and us. And Gerard, well, I guess we are at the end of the show. See you next week in Amsterdam, as every year. Let's hope we have some good weather over there.
Yeah.
And we will enjoy all together a nice IBC
show.
Yeah,
well, thank you so much for the opportunity. Thank you for everyone that's joined and listened. And yeah, see you at IBC.
Thanks so much. Thanks everyone for joining, and hopefully see you all at IBC. And if not, feel free to reach out.